Hello guys, good day to everyone. Let me just introduce myself first. I am Engineer Adams Vice A. Janisha, a licensed civil engineer, a faculty member, a BSCE graduate, and a graduate student at University of the Philippines, Diliman, with a specialization on structural engineering. And this is my email, adamsroycejanisha@gmail.com. So you can contact me via email or you can just search my name on Facebook or Messenger if you have any concern. And welcome to my online lecture class. So our subject is still C009, Mechanics of Deformable Bodies. So just a disclaimer, this presentation is not perfect. So it might contain some errors that need my attention. So if you see any errors or corrections that need to be made, please immediately notify me. And not everything that the student needs to know is presented here. So I hope the student will supplement this discussion or presentation. And lastly, the photos, problems, etc. you will see on this presentation is not owned by the instructor. So credit goes to the respective owners. And please do not distribute or disseminate this presentation on any online platform without my or without the consent of the instructor. So the references that I have used on this presentation, still Engineering Mechanics by Hibeler, Vector Mechanics for Engineers by Beer et al. For some images, for clarification, and for better visualization, I have used Google. And in some content, I have used Matrix Analysis of Structures by Casimadi. And last but not the least, Engineering Mechanics Statics by Craig et al. For some sample problems and problem set. So, just to recap what we have studied last meeting, alalahanin lang natin ano ba yung mga pinag-aralin natin last meeting. So, una dun sa mga inaral natin last meeting ay yung mga different assumptions that we assume usually first before we start to analyze a beam. And una dun sa mga assumption na yun is number one, we assume na yung beam itself ay rigidly joined together. Meaning, every part of the beam is connected rigidly or fixed yung connection nila. Ibig sabihin lang nun, if we will try to disconnect those parts, may lalabas ng mga internal forces, which is in the case ng fixed connection, alam natin na pag pinaghiwalay natin or disconnect natin na ang isang fixed connection, may lalabas na dalawang forces, vertical and horizontal usually, at isang moment, which have equal magnitudes but opposite in direction on each part na disconnect or pinaghiwalay natin. So that's our first assumption when we analyze a beam. Second assumption is that we assume na yung mga load na kinakarga ng isang beam, lahat ng yon dumadaan dun sa tinatawag na longitudinal axis or centroidal axis ng beam. Dahil lang ay yung ibig sabihin ng assumption number 2. So, kahit anong orientation pa niyan ng load na yan, we assume na dire-diretso siya doon, dumadaan siya doon sa tinatawag na longitudinal axis ng beam. Usually, we assume na yung plane that contains that load applied to the beam, which also contains the longitudinal axis. Usually, we assume na yung plane na yun ay isang vertical plane. So usually ganun yung assumption natin, yung dinadala na load ng isang beam is contained in a plane, usually a vertical plane, which also contains the longitudinal axis of the beam. Although hindi naman laging vertical plane, pero most of the time vertical plane. Ibig sabihin, lahat ng loads natin usually pa vertical. Although hindi naman literal na vertical, ibig sabihin lang, yung load is contained on a vertical plane, but not necessary na yung orientation niya ay pa-vertical. Pwede rin ng mga pa-diagonal or kung anumang direction pa. Third assumption, we assume na yung weight ng beam ay uniformly distributed all throughout its length. Ibig sabihin, parang if we will try to represent the weight of the beam using a diagram, we can assume na yung tsura ng weight or yung weight distribution ng beam all throughout its length ay uniformly distributed load. Pero usually, that is in the case of prismatic beam. So when we say prismatic, ibig sabihin, yung cross-sectional area niya all throughout its length, pare-pares lang ng itsura. Minsan kasi merong mga beam na tapering, kumbaga. Ibig sabihin ng tapering, hindi pare-pares yung cross-sectional area niya all throughout its length. Usually, nagbabago yung size, yung dimension, kumbaga. So, syempre, pag ganun yung case, hindi na natin pwede ma-assume na uniformly distributed yung weight niya all throughout its length. So, that's a different story. Next assumption, we assume na yung beam natin ay in equilibrium. Meaning, kapag nag-sum up ka ng mga forces as well as moments, dapat equal sa 0. Ibig sabihin lang nun, the beam has no tendency to displace and wala rin siyang tendency to rotate. So that is what we meant by equilibrium. So yun yung ibig sabihin natin kung in equilibrium yung structure natin. Fifth assumption, we assume na yung mga internal forces na lalabas when we disconnect one part of a beam to another, lahat ng yon we assume na nag-a-act sa centroid ng cross-sectional area ng beam. And lastly, we assume na kung magka-cut tayo, or kung maglalagay tayo ng cutting section dun sa beam, we assume na yung cutting section na yun ay palaging perpendicular sa longitudinal axis ng beam. So, hindi naman requirement talaga na perpendicular, pero again, we usually assume na perpendicular siya yung cutting section natin. Kung magka-cut man tayo, kung maglalagay man tayo ng cutting section dun sa beam. Another thing na inaral natin last meeting ay yung paano ba i-analyze ang isang beam. So, we have found out na merong isang method para ma-analyze natin yung beam, para malaman natin yung mga internal forces na nag-act sa kanya. And ano yung method na yon? Yung method na yon ay katulad lang ng method na ginamit natin sa truss, which is yung method of section. So, in this case, in-apply lang natin siya sa beam. So, by definition, parehas lang naman sila. Ano bang sinasabi sa method of sections? If a body or structure is in equilibrium, therefore, dapat lahat ng segment ng body na yon na mabubuo when you cut that body, dapat lahat ng segment na yon, they must be also in equilibrium. Ibig sabihin, pag nag-summation ka ng mga forces tsaka moments, dapat equal yun lahat sa 0. So those are the methods that we have found out na pwede nating magamit to analyze a beam. Actually, meron pang isang method pero hindi ko na siya dito diniscuss sa beam. dito ko na siya ngayon i-discuss sa next topic natin, which is obviously analysis of frame and machine. So our goal for this meeting, una, just like our goal dun sa analysis of truss and beam, ang goal natin for this meeting is maunawaan to understand the different assumptions made and method used when analyzing frames and machines. So, just like from the previous topics, we have to first understand ano ba yung mga assumptions na ginagamit natin or ina-assume natin kapag nag-analyze tayo ng mga frame as well as machine. And ano ba yung way para ma-analyze yung mga frame and machine na to. Second goal natin is after natin malaman yung mga assumption na yun and yung method to analyze a frame and machine, so apply na natin siya into analysis of frames and machines. So yun yung second goal natin, actual implementation kumbaga.
Are you still looking at me?